So today I'm going to start the class regarding the contrast sensitivity. So what is the definition of contrast sensitivity? The ability to perceive the slight changes in luminance between the regions which are not separated by the definite borders, and is just as important to ability to perceive the sharp outlines of a relatively small object. It is the ability to detect the separation of the area of different contrast level. So as you can see in the spatial or the image, this is the spatial frequency of a image. You can see the black and white strips, the black and white strips you can see as it's going toward left to right, the strips are going narrow in size. The strips are going on narrow. So this is the contrast level. So this is the contrast level from invisible to visible surface. So what are the types of contrast sensitivity? So it's a spatial contrast sensitivity or a temporal contrast sensitivity. So spatial contrast sensitivity is the detection of a strip pattern at various levels of contrast and spatial frequency. So this is the spatial frequency I'm talking about. So sine wave gratings of parallel light and dark bands are there. So this is the dark bands and sine wave gratings are there. Width of the bar is defined as a spatial frequency. So you can see the it's going from left to right, it's getting narrow, and this width of these strips is known as a spatial frequency. So spatial frequency narrow bars. So this means if the patient having a good vision or high spatial frequency or high level of contrast sensitivity, the bars will be narrow, the bars will be toward the right side, means vision is good. If the low spatial frequency, there will be a white bars. If the patient will getting the only the left image, that's a white bars, that means the patient having a sometimes of low vision. So low spatial frequency is the white bars and high spatial frequency is the narrow bar. So spatial frequency increasing exponentially from left to right, as you can see in the image. The contrast also varies logarithmically from 100% at the bottom to about 0.5% at the top. So next is the temporal contrast sensitivity. So contrast sensitivity function is generated from time related processing in the visual system by presenting a uniform target field modulated sinusoidal in time. The shape of the contrast sensitivity function varies with the factor luminance. It depending upon the shape and the means the contrast sensitivity is totally depending upon which factor, that is the light, that is luminance, what is the size of the target, what is the grating motion, what is it's the grating motion is sharp or not. So totally temporal contrast is totally dependent upon the this frequency. So normally temporal contrast sensitivity is totally depending upon our visual system. So next is a measurement of contrast sensitivity testing. So first is a Pelly-Robertson chart, Bailey-Levy chart, Cambridge low contrast grating, Regan charts, functional acuity contrast sensitivity chart, and Arden plates test. So as you can see in the Pelly-Robertson chart or Pelly-Robertson contrast sensitivity charts, so upper letters are bold as compared to lower one. So means the frequency of the sine wave gratings of the upper is very, you can say, just like a narrow bar or a wide bar. Just like this, the high spatial is a narrow bar and low spatial frequency is a wide bar. So mean to say the patient with a good vision with increase with get the vision or with get the contrastivity of high spatial frequency at the lower one. If the patient can read the last line easily, just r z r s z v r, that means the contrast sensitivity is very high, means the patient vision is very good as compared to the abnormal one. If the patient is reading just the upper one or the few lines of the upper ones of the, that means the patient have some default in the contrast sensitivity. So letter of the same size but with reducing contrast will be there. Two charts and two scoring pads are there. Each chart had a 6 letter in each row organized with two triplets of varying contrast. Illumination is chart is about 85 cyclic diameter millimeter of 21 meter distance. So we will perform at a 21 millimeter distance. The score of a test is recorded by the faintest triplet out of which at least two letters are correctly identified. The log contrastive value for triplet is given by the numbers on the curve. So mean to say, so these charts are normally designed for what? Whenever the patient having some disease, with disease, the patient having, as you know, the abnormality of vision is there. With abnormality of vision, there is also reduction in some contrast sensitivity. So we have to find out, is there any contrast defect also? Okay? Because some of the disease, some of the like optic nerve disease, have mainly the contrast sensitivity related diseases. So next is a Bailey-Levy chart, that is a low contrast acuity testing or acuity testing in a presence of a glare. Each row has the same number of symbol and constant spacing in using between the rows and letters. Chart is logarithm based and visual acuity is based in the log of a minimum angle of resolution as a logmar. The Berkeley glare test provide 10% of contrast and provided with glare source. So same, this is the Bailey-Levy chart. So this is also help in providing the contrast sensitivity. As you can see, the upper two or three lines says about that the vision is not good enough to getting the or vision or the contrast sensitivity level is not good enough. That's why the patient is just reading the upper three lines. If the patient can read up to near smallest letter or the smallest, you can say the 2 to 3 letter, that means the patient has a good contrast sensitivity level. So next is the Cambridge low contrast sensitivity or grating. It is a rapid and simple screening test for a contrast. It performed at a distance of 6 meter. It comprises of a 12 pair of consisting of straps of varying contrast. First one is for demonstration. Demonstration means to so that we can teach the patient what are we trying to do, and rest are for proper testing and number from 1 to 10. The plates are changing sequentially starting from plate 1 till the patient fails to respond. So you can see in the image the upper circles are is getting a almost a black and white strips, black and white strip with a white type of black and white strip. At the lower one is getting the narrow type of white strips. So narrow, or you can say the lower one, if the patient can identify the 5 to 6, almost 7 to 8 9 hold the circles, that there is a black and white strips out there but it's in narrow inside, that the patient vision is contrasted is good. If the patient saying that the upper one is where patient is visible, or see upper one is visible, that means the patient vision is not enough good due to some diseases. Four such series are completed and the score of each series is noted and added. The final total value is converted into a contrast sensitivity from the provided table. So next is a low contrast Regan low contrast letter chart. So it consists of three letters. So same you can see in the image. A, one of the four Regan low contrast acuity charts, high contrast, and C1 is a repeat letter chart. So in this 3 meter with 8 letters in each line is going on. Patients are instructed to start at the top and to continue reading until they can correctly identify the letters on the line. For one chart size goes on reducing, contrast remain constant. Regan in 90 suggests the chief role in detecting early visual loss in diabetes and glaucoma. So whenever there will be early loss in glaucoma or diabetes, so we can go for a contrast sensitivity. We can detect the early losses by contrast sensitivity easily. So this is the chart. As you can see the chart in the first and the second one. The first and the second one, you can see the letters are reducing. So as the letters are reducing, that means the narrowing frequency is going on and the patient vision or patient spatial frequency is good. And the C chart, it is a repeated letter charts. So mainly to identify the equal sizes in the presence of when the patient is saying that the lower one the patient can't see. The Arden plate test, it is introduced in the 1978. It consists of a booklet containing several sine wave grating patterns. Each grating is oriented vertically. The contrast vary from top of the bottom of the grating, lowest at the top and highest at the bottom. So you can see the C image having a white type of narrow strips. B is also white type of more white, and the A is a narrow. So narrow says about high spatial frequency, means good contrast level, B1 and C1. B1 is totally abnormal because the you can see in the black white strips it's been faded out because of the some diseases. And C is also been white, but the uh, but the large one, the C1, is also saying that the abnormal of the optic nerve disease or due to glaucoma or due to diabetes. So this is about the